that's reason to celebrate, right? So we're looking at problem number 16 on page 424, and I used some shorthand here to write it because I got tired of writing. But the question reads, there was a 100-day period when the number of bees in a certain hive could be modeled by the function n below. In the function, k is a constant, and n of t represents the number of bees on day number t for t between 0 and 99, between and including. On what number day was the number of bees in the hive the same as it was on day number 10? Whoa! So this is a doozy of a problem. This is the perfect problem for the College Board to use at the end of a test, because this really gets our brain working. There's lots of information here and lots to work with, and I actually skipped something that's essential to the problem, so I'm going to write it over here. I skipped the function that we're given, which is n of t is equal to t squared over 2 minus 20t plus our constant k. So that's important we have that in there, otherwise we won't be able to solve this thing. Okay, so who, what, when, where, and how. The what question refers to what kind of problem this is, and this definitely falls into the algebra category. The when question refers to the amount of time that we have going into this problem, and this is number 16 of 16 in this section, so we're probably either real short on time or we might not even get to this problem on the test. And then the where question refers to how hard this problem is going to be, and since this is 16 of 16, this is going to be a hard one, and you can probably even tell that from just looking at this function here. This is going to require some serious algebra, which gets us to the how question. A lot of times we're able to get around using some algebra by plugging in numbers or plugging in the answer choices and working backwards that way. There's kind of no way around doing the algebra here. We see that these numbers represent day numbers, which isn't going to help us. These answer choices are not going to help us. So we're going to have to use algebra here to solve this guy. So the who question is either you or not you, meaning you're either going to do the problem or you're going to choose to skip it, and that decision is up to you, but this is definitely possibly a skipper because it's tough and it takes some time. So let's go into the method for solving this problem. Alright, so the first thing we want to do is highlight anything we're given that's going to be essential for us. So we're given the function. Now let's talk about what the function refers to. And remember that they tell us n refers to the, I'm looking at the actual problem here because I can't read my own handwriting. N represents the number of bees on day number t. So n represents the number of bees, t represents the day number, and k is some constant. So we've defined our variables, and I'm actually going to define them down here. It's a good thing to define your variables if you have the time, because then when we actually go back and figure out what we're solving for, we know what these variables represent. So n represents the number of bees on day t. T represents the day number. And k is a constant. I don't have to mark that down. I'll remember that. Okay, and so what are they asking us to solve? So they're asking us on what day number, means we're going to be solving for t, because remember t represents the day number. On what day number was the number of bees, was n, the same as it was on day number 10? Alright, so this 10 we're definitely going to use. And how are we going to use it? Well, let's solve for what the number of bees was on day number 10, right? We can do that because we know that 10 represents t, and we can just substitute 10 for t in the function that we were given, right? So let's go ahead and do that. So we're going to be solving for n when t is 10. So we're going to find n of 10, and that's going to be equal to t squared, which now we're just substituting 10 for t, so 10 squared over 2 minus 20 times t, which we're substituting 10 for t, plus k, and that'll give us the number of bees on day number 10. right? So if we do some simplification here, 10 squared is 100, over 2 is 50, and we're going to get 50 minus 20 times 10 is 200, and then plus our constant k. So if we do 50 minus 200, I believe we get 150, and then we still have that plus k, or that constant. All right, so we've done something here, but the question is, how are we going to use this? What's our next step, right? We found the number of bees when t was 10. We found the number of bees on day number 10, but it's in terms of k, right? We still don't know this constant, and we're probably going to need to know it because we notice our answer choices don't have a k in them, right? Okay, so what can we do from here? So here's the interesting part. Remember, we're solving for t. We're solving for the day number when the number of bees is the same as it was on day number 10. Well, the number of bees on day number 10 is that, right? So what we're going to do is we're going to solve for t and set this part equal to n. So we're going to do negative 150 plus k. This represents the number of bees on day number 10, and we're going to set that equal to t squared over 2 minus 20t plus k. All right, so now when I do this, notice I can take away the parentheses. Those aren't really doing anything for me, and I'm going to do that just to make it a little bit easier to see what's going on here. Because if you notice, I have a plus k on both sides, right? Now the cool thing about this, we really like this, because when we have a plus k on both sides, if I was to subtract k from both sides, the k's are actually going to cancel out, which is really cool, because then what we're going to get is we're going to get a quadratic equation, and it's just going to be in terms of t, and we can actually solve this thing now, right? So from here, it's just a little bit of algebra to solve for t, which represents the day number. Remember, it represents the day number when the number of bees is negative 150 plus k. So the way I like to do it is I like to get rid of this 2 first. So I'm going to multiply both sides by 2. And I'm going to get, on the left side, I'm going to get negative 150 times 2, which is negative 300. And then on this right side, I'm going to get 2 times t squared over 2, which is just t squared. Those 2's are going to cancel. And then I'm going to get minus 20t times 2, which is minus 40t. And then if I'm solving a quadratic, I want everything on one side of the equation, and I want to set it equal to 0. So I'm going to add 300 to both sides. And when I do that, I'm going to have to move up here. When I do that, I get 0 equals t squared minus 40t plus 300. Okay, so I'm sorry that this is getting all crunched and you probably can't read it. Let me actually go up here because we have a little bit of room. So I'm going to rewrite this. 0 equals t squared minus 40t plus 300. Okay, so from here, we can either use the quadratic equation to solve this because we have a quadratic, right? We have a squared term and a t term and then a constant. So we can use the quadratic equation, or we could see that this thing factors. And the way it factors, and if you don't see this, that's okay because you can solve this using the quadratic equation, but this guy just factors as t minus 10 times t plus 40. Okay, and so then we can just solve for t, and we see that t equals, what did I do here? I factored it incorrectly. Oh my gosh. That was embarrassing. All right, the factorization is t minus 10 times t minus 30, and let's talk about why it factors this way, since I now just completely confused you by factoring it wrong initially. So again, if we're factoring, we're looking for two numbers that add to negative 40, which negative 10 and negative 30 add to negative 40, and then those two numbers need to multiply to 300. So we see that negative 10 and negative 30 do multiply to 300. So that's why those are our two factors there. Using the zero product property, we can now solve for each factor, and we get t equals 10 and t equals 30. All right, so we get two answers, which if we go back to the problem, it makes sense. Remember that negative 150 plus k represents the number of bees on day 10, and then what we were trying to find, it also represents the number of bees on day 30. So that's our answer. B. The number of bees on day 10 is equal to the number of bees on day 30, and that's why our answer was B. So yeah, this problem was kind of a bit of a pain, right? Lots of algebra, we had a constant in there. This is as hard as it's going to get on the SAT probably. So if you can do this, you can do anything, I promise. That should be good news.